Hey guys, welcome. I hope you guys are having an awesome day. It is March 18th, 2020, and let's get right into it, guys. And I think you guys will like today's lesson because it's over vectors. A lot of you have some experience with it, so let's get started. So you use vectors all the time, guys. What's a vector? A vector has magnitude and direction as opposed to a scalar, which just has magnitude. And you use vectors all the time to such as quantities such as force, velocity, displacement. All of those quantities have magnitude and direction. So visually, how can you express a vector? If we want to use an arrow here, a vector. So here's a vector, and I'm going to call that vector A, and I'm going to keep it with the color like so. Sometimes they do that, and they say that's your vector A. I've seen many books use that, or they'll put an arrowhead in the top. It doesn't matter, guys. Whichever one you feel most comfortable. So if that's vector A, and I duplicate this, so I'm going to write it right over here. And I'm going to go ahead and rotate this 180 degrees. So there it is. I rotated it 180 degrees. Now you can see the magnitude is the same because it's still the same length. But now I'm facing the opposite direction. So you would call this negative A. And this time I'll put an arrowhead up there. So there it is. There's my vector, guys. And it really is that simple. If I did 2A, then I would just draw two arrows facing each other, connecting from tail to head and then tail to head again. So it's pretty basic. So here we go. It says A, and then notice there's an arrow on the top, equals 3I plus 4J. Now, don't get scared here, guys. This 3I, the I is common language in the math and physics world. This indicates, if I'm in a two-dimensional space, this indicates movement in the x direction or displacement in the x direction. So sometimes they call it displacement. And then this 4J indicates movement in the y direction, because at the moment we just have two dimensions, either x or y. X being horizontal, y being vertical. So let's go ahead and start, guys. So it says that my vector is 3i plus 4j. So this is called a position vector. If I started right at the origin here, so I'm going to go ahead and start it at the origin. And I'm gonna move 3 times to the right, and I'm gonna move 4 times to the left, 4 times up, sorry, and I'm gonna terminate there. So I'm gonna start at the origin. So here we go, and then I'm gonna go 3. Oh, that's not an arrow at all. Here's my arrow. So I'm gonna start here at the origin. I'm gonna go 3 to the right, and then 4 up vertically. So there I am at 3, 4, and that's my vector, guys. There it is. That's really how simple it was. If I were to move this, so I'm going to go ahead and duplicate it. If I move this around, this vector here is still, this one that I just wrote right now is still 3i plus 4j. But notice it doesn't start at the origin anymore. So now that would probably be called a displacement vector. They don't usually call it that. Sometimes you have an initial point and an ending point, and they're like, find that vector. And we're going to do that today, actually. So there it is, guys. And that really is how simple it is. Am I able to delete that? Let me delete that. Okay. So I'm going to go ahead and do this vector here in blue. So it says 3i plus 2j. And this is not the only way. You could also display it. Let me display it a different way. You can also display this vector with chevrons. So you write that chevron like that. That's what this is called, this bracket here thingy. It's called a chevron. And I'm going to write 3, comma, 2. Where that 3 is horizontal or x direction. Motion in the x direction, and this right here is your displacement or motion in the y direction. So it's the same thing with the one up here, guys. If you wanted to display vector A in terms of with chevrons, you would write 3, 4, and then close your chevron there. So here we go. I'm gonna continue, and I noticed that I do not have a blue arrow, so let me see if I can insert that. Where are my arrows? Shapes. Arrow, blue. All right, so let's see. I'm going to go from 3 to 2. So 3 and then 2. Well, there it is. It's not perfect. You kind of want that arrowhead to be touching that point right there. Now it says find the sum of A and B. All right, I'm going to do this in the neutral color. I'm going to do it in black. I'm not that black is a neutral color, but you know, whatever. So the way you add vectors, guys, I'm going to go ahead, and the way you add vectors is you add components together. So what I mean is you find the x components, so that's a 3, and you're going to add them together. 3 plus 3, comma. And then for the y component, the y movement, you're going to do the 4 and the 2. 4 plus 2 is 6. So for now, I'm just going to write 4 plus 2. And so I'm going to say that my resultant vector, 3 plus 3 is 6, 4 plus 2 is 6, is 6, 6. And the way you add your vectors, so here's vector A in red, and then the vector B in blue. So when this one terminates, the arrowhead of angle A, I'm going to put this one right on top of, it's not perfect yet. There we go. And there it is, guys. Now, I want you to pay a close attention here, or I want you to observe something. So I'm going to call this a resultant vector. Insert, and where are you? Shapes, arrows, and I'm going to do a green one this time. I want you to check this out, guys. So this vector is called your resultant. Result. So when you add those two vectors up, you get from the origin, you get this resultant vector. This is like your net vector or your displacement vector. So I want you to observe that this terminates. So in the x direction, I move 6 times to the right, and in the y direction, I move 6 times up. That's a 6 there if I move that. And there it is. It's not perfect, but it's 6, 6. So I think that's kind of cool, guys. So I hope you guys are liking that. Let's keep going. So now we have a whole bunch of vectors. It says, what if we have multiple vectors and we lay them, and let's say we have A, B, C, D, and then find all the sum of all 4 vectors numerically and find the sum graphically. So I'm going to go ahead and use all the colors that I have available at my disposal here. So let's go ahead and start. I'm going to start with the green one, I guess. So this A is going to be the green one. So here we go. So 3, 4. So I'll start at the origin. I'm going to go to 3, and I'm going to go up to 4. And then I'm going to change the color. I'm going to go to blue. So -2, 4. So I'm going to go -2, and I'm going to go 4. So -2, 4. And they're not perfect, but they're as good as we can get them here. So let's see. We've used green. We used blue. Let's use red. So 3, 2. 3, 2. Perfect. And then 1, -1. So let's use yellow. Yellow might be kind of hard to see. 1, -1. There you go. So we're going to add them all up. That's what we're going to do here. Let's color code this real quick. This was the green one. -2, 4 was blue. Then we used red. And then finally yellow. Well, I don't have yellow in here. So let's use, okay, you guys know, yellow. All right, we're going to add them all up. So to find the sum, so they want us to add A plus B plus C plus D. So let's add them all up component-wise. So all the x's together, all the y's to get together. So I'm going to draw a chevron here. So let's see, 3 plus -2 is 1. 1 plus 3 is 4, and 4 plus 1 is 5. So if I didn't do any mistakes, I see 5. Let's do the y component vector. 4 plus 4 is 8. 8 plus 2 is 10. 10 minus 1 is 9. So I see 9. And I probably should have used black, right? Because that's the color that I haven't been using here. So sorry if I've confused you guys. I don't think I have, but in case. All right. So now, our resultant vector, if I add everything up, should end up at 5, 9. Or should look like vector 5, 9. 5 to the right total, 9 up total. So we're going to start adding these suckers up, and let's see if that's the case. So let's see. The blue one, I'm going to add it to the green one. There we go, more or less. That's about as good as it's going to get there, guys. Now, let's go ahead and do the blue one, the red one now. 3, 2, head to tail. That looks pretty good to me. Maybe a little back. I had it pretty good. Okay, well there it is, 3, 2. And then finally, the yellow one here. Well, I accidentally moved it or made it a little different. So let me go back here if I'm allowed. Alright, I'm going to delete this one, guys. I'm just going to put another arrow in here because I accidentally moved. I messed with the toggle. I changed the skewness of it. So there it is, 1, -1, and I'm going to add it to the vector that I have up here. And I want you to pay close attention that the resultant vector, and to save time, I'm just going to go ahead and just use this one here, guys. Looks like that. And notice that that is 5. And the at y value is 9. So we're good. It looks like everything worked out. Resultant. Cool or not cool? I think that's really cool, guys. I hope you guys are having fun. All right, let's see what it says here. All right, the vector A have an initial point. The vector A have an initial point. Has an initial point. So right has at 2, -5. So I'm going to put a point at 2, -5. So 2, -5 point. And a terminal point. So terminal point means where it stops. At -2, -8. So -2, -8 points. Determine the components of the vector A. Also find the exact value of... Okay, what this means here... I've also seen it with absolute value instead of these double lines there. That means magnitude of A. That means magnitude of A. So don't worry. I'm going to help you guys with that. So I have from 2, -5 to -2, -8. So here's my vector. 2, -5 to -2, -8. There it is. Now, I want you to notice, what did it say? Determine the components. All right, so determine the components. So what is my x and y components? So how many times did I move to the left? I moved 1, 2, 3, 4 to the left. And I can see just by doing that right here like that. Oh, I went too far. 1, 2, 3, 4. And then how many times did I move down? 1, 2, 3. So my component vector, A, is nothing more than 3 to the left, so -3. And then 4 down, -4. And there it is. That's my component vector, which just means your component, your x and y. Now, they want to know the magnitude of it. Notice I have a right triangle there. So if I want to know the magnitude of this triangle, I can just do Pythagorean theorem, guys. So my magnitude, I'm going to do the double like so. The magnitude of this vector is the square root -3 squared. Now you don't have to put a negative in there, guys, because I'm gonna square it anyways. And then -4 squared. So 3 squared is 9, 4 squared is 16, 16 plus 9 is 25. So the square root of 25 is 5. So there it is. That's my magnitude of that vector. If they ask for direction, then I would do arctan of 4/3, and I would get a positive angle, and then whatever that is plus 180 to get it looking like right there, because it's always with respect to the horizontal. And I'm going to ask that in a little bit, so it's okay. And there it is, guys. Cool or not cool? Cool. All right. All right, Chavez, but what about multiplying a vector by some scalar? So it says, given vector A, and I have a vector A, and it says -2, 1, and it wants me to find 3A. What does this mean graphically? Well, all it really means is that you have 3 of vectors of the magnitude A. So it's like writing this vector and then putting 3 of them back to back to back and then adding them all up head to tail, head to tail, head to tail. That's what it really means. So 3A just means 3 times -2 and 1. So when I multiply that by 3, so let's see, 3 times -2 is -6, and then 3 times 1 is 3. So that's where it's going to terminate. So that's all it means. So let's see, and let me see if I can draw this for you guys so you guys can see what I mean. So negative 2, 1. So negative 2, 1 looks like so. And if I duplicate this 3 times, duplicate, 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 and I add them, oh, we got in emails like crazy, and I add them, let me get this guy and add that guy. So I didn't do a good job. Oh, I put 4 of them, huh? All right, let me delete this one here. Delete. Delete. Now, but let me see if I can do a better job with the mouse here. Nope. Nope, I just changed it. Let's go back. Well, you can kind of see. No, you can't, right? Because I kind of messed it up. Oh, now what? So it kind of looks, I didn't do a good job, guys, and my apologies, but you can kind of see that this vector is adding up to negative 6, 3. I wish I would have could have done it, a lot cooler than that, but oh well. Sorry, guys. And then it says here, Chavez, I was looking at the online question, and they were asking for component form, followed by magnitude, and then finally the direction of the vector. Help. I'll never do that again. My apologies. All right, so this is an excerpt from Delta Math, and it says I have an initial point at 6, negative 3, and a terminal point at 2, 1. So my initial point, 6, negative 3. So 6, negative 3 points, and then I'm going to go up to 2, 1. So you can already see you're moving left and you're moving up. So here's how that vector looks like. And then it says, find the component form of that vector. All right, so the component form of that vector, they're calling it V. So the component form of this vector, oops. Does it not delete? Delete. Is like this. Component form. I went how many times to the left? 1, 2, 3, 4. 4 times to the left. So negative 4. And how many times do I go up? 1, 2, 3, 4. So 4 times up. And there it is. There's my component form. Now I want the magnitude of it. So the magnitude, I guess I'm going to do, let me do it with math symbols. The magnitude of V is nothing more than negative 4 squared plus 4 squared. And let me put this in tablet mode. So there it is. So 16 plus 16 is 32. And I still have the square root of that. And the square root of 32. So remember that I can get this by going 16 times 2. So the square root of 16 is 4. So I have 4 square root of 2. So there's my magnitude. And then finally the direction. So the direction of the vector, so let me draw this in black here. It's always with respect to the horizontal. So Chavez, what does that mean? The positive horizontal. So imagine this right here is the origin. And in a little bit, Delta Math is going to make you put that in the origin, which might be ideal. So imagine this is the origin here. I want to know what this angle is right there. So you guys see that? So you already know that my vector is negative 4 to the left and 4 up. So I can just do arctan of negative 4 over 4. Chavez, what are you doing? I'm just doing this. Here's my reference angle. I went 4 up, and I went 4 to the left. See? So I guess technically it should be opposite over adjacent, so 4 over negative 4. I still get negative 1. So this is arctan of negative 1. And then you ask yourself, on the unit circle, where is tan equal to negative 1? It happens in quadrant 2 and in quadrant 4. It can't be quadrant 4 because that would be a negative 45 degrees. And this theta here does not look like a negative 45 degrees. Remember, it's always with the positive horizontal axis there, guys. The positive horizon, the positive horizontal. So that degree there has to be 135 degrees. Now, in case you are like, oh my God, I don't know how I'm going to do that. you can just go in your calculator, you can go arctan of -1, and the calculator will spit out -45, and then you go -45 plus 180, and you'll get the 135 degrees. I think Delta Math does do arctan of 4/4, and then you find that the reference angle here is 45 degrees, and then you know that the distance from here to here is 180, so I think Delta Math does 180 degrees minus the 45 degrees, which you still get the 135. It doesn't matter how you do it, guys. Just make sure you know how to do it. And there it is. It really is that simple. I hope you guys had a good time. I hope you guys enjoyed it. I hope you guys liked this video. If I confused you, please let me know where I confused you guys, because, you know, I would like to talk about it. I'm going to continue. I'm going to show you guys how we do this question. I just got to take a quick pause here so I can fix everything. And yeah. All right, guys. So I hope you guys were happy about this, and let's continue it up. All right. Hey, guys. Welcome, Math Life. And so here we go, guys. Let's try this question out. So again, it's the same one that we just did. So let's just go ahead and finish this up the way it looks on Delta Math here. Let the vector B have an initial position at 6, -3 and a terminal point at 2, 1. Plot the vector V and afterwards follow the guidance test tunnel as a vector. Okay. So first start by plotting in this point. So it's 6, -3. So here's my vector, or here's my point, 6, -3. And I'm going to go towards 2, 1. So there is 2, 1. So there it is. There's my vector, guys. And that says move the vector so that its tail is at the origin. So I'm going to move this dude. Bam. And then I get, it says that's right. Now answer these 3 questions below. And we already did this component form. So now it's easy to see here that since it tells that the origin and the head is right here, it's easy to see that in the x direction you move 4 times to the left. So you just put -4. And then in the y direction, you move 4 times up. So I put a 4 there. And then the magnitude of that vector, well, let's see. 4 squared is 16. 16 plus 16 is 32. So it's the square root of 32. And what did we say it was earlier, guys? We said it was 4 square root of 2. So I'm going to put 4 square root of 2. And then for that angle, remember we said that was like arctan of -1. So that's either going to happen in quadrant 4 or quadrant 2. It's very obvious by this picture here that I'm in quadrant 2. So that happens 135 degrees. Now, not all of them are going to be perfect degrees. That's why it says here nearest degree. So sometimes you got to do that. And then when you submit it, you're going to get a nice question, a nice check mark. Cool? Cool. All right. Let's continue, guys.